Good afternoon. Thank you for coming to my talk. This is going to be a talk on the caves of Minnesota and how the geology of the area affects the nature of the cave development. So firstly, we're just going to have a little introduction to myself. My name is Nick Seaton. I'm a geologist. I work at the University of Minnesota. And I started caving in England when I was an undergraduate at Liverpool University in about 1998. And in 2007 I moved to Minnesota. Shortly after moving here I joined the Minnesota Speleological Survey, and after a few years I was voted onto the board and I became the president of the club. So on this map here, for anyone who doesn't know where Minnesota is, we're up here on the Canadian border in the middle of the US. And the colours on this map represent various types of karst-forming rocks. The greens are limestones, carbonate rocks, dolomites. And the dark green is exposed bedrock at the surface, and the lighter green surrounding it is what we call buried karst, which is usually under at least 10 to several hundred feet of soils. In the case of the upper Midwest here, the coverage is glacial till from the recent glaciations, and the exposed stuff is exposed for two reasons. One, in the river valley of the Mississippi, is that the Mississippi has actually cut through the cover. But the second reason is, particularly in the southeast corner of Minnesota, northeast Iowa and western Wisconsin, is an area known as the driftless. The driftless is called this because there is no glacial drift or till covering the area. The most recent glaciation, the various glaciers, the lobes went down this side and across this side and missed this little piece in the middle here. And so we didn't actually have any extra soils and rock debris deposited from the last glaciation. So this left the limestones here exposed at the surface and therefore able to have caves developed in them. So now we're going to discuss a little bit about the geology of the area. So firstly, we can see that southeast Minnesota, like many of the cave-forming regions, the rocks were formed a very long time ago. In the case of southeast Minnesota, the caves are actually formed in Ordovician limestones. The Ordovician was from 488 to 443 million years ago. And directly after the Ordovician, we have the Silurian period. And this is actually a picture from the Smithsonian Museum of a Silurian period seafloor. But it would have looked very similar during the Ordovician. You essentially have some carbonate muds on the seafloor with some corals and sponges growing on them. We have crinoids growing. We have little shellfish like brachiopods and gastropods, snails crawling around. And then we have some bigger critters, some trilobites and some nautiloids like Orthoceras, which is the predecessor of the modern day squids. So, although this is a Silurian picture, it would have looked very similar during the Ordovician. So, once all that stuff is deposited on the seafloor and buried, it gets squashed down, and most of it becomes limestones. We can see here for a generalized rock section for Minnesota, and at the very bottom we have the Precambrian period. This is before life came around. And mostly we have the metamorphic basement rocks from Minnesota, granites and gneisses, on top of which we've got a bunch of sandstones that stretch up into the Cambrian here. And this boundary here is where life appears at the Precambrian boundary. And most of the Cambrian rocks in Minnesota are sandstones derived from these other igneous and metamorphic rocks. But eventually at the top we start to get into carbonate rocks here in the St. Lawrence limestone. Most of the major caves in Minnesota are formed in this upper Ordovician Galena group and Dubuque formation. Some of the other caves in the area, Crystal Cave in Wisconsin and Kruger Cave in Minnesota, are formed in the Prairie du Chien group of the lower Ordovician here. This is a more sandy dolomitic limestone. You can see it's bounded on either side by sandstones, the Jordan and the St. Peter. Many people will have heard of the St. Paul caves. Most of them are not actually real caves. They're man-made mines and tunnels, and they were all formed in the St. Peter sandstone because it's a very poorly consolidated sandstone that lets people mine it very easily. It's a very pure quartz. For instance, beneath the Ford plant in St. Paul, they mined it to use as the glass for the windshields of the trucks they were making. And then in the lower Cambrian sandstones, we have a few caves, and these are mostly erosional style caves in the outside river bends or slump blocks from bluffs that fall down and form a cave behind it. But yes, most of the major caves in the area are formed in this upper Galena group. So if we take a quick closer look here from the Galena, we can see that it's broken out into 3 subunits: the Cummingsville, the Prosser, and the Stewartville. And then above that we have the Dubuque and then the Maquoketa. Most of the caves, such as Mystery Cave and Spring Valley Caverns and Niagara Cave, their initial formation horizon, it tends to be in the Dubuque and often at the actual join of the Dubuque and the Maquoketa. And then they erode down through various layers, but most of them don't get below the Prosser. We can see the numbers on the left here actually are measurements in feet of depth, and each one is 50 feet more. So from the point when they originated, most of these caves are 100 to 150 feet from their highest point to their lowest point. The Dubuque formation itself is a very thinly bedded limestone with many shale horizons in it. This gives way to the Stewartville limestone, which is a more massive, blocky limestone. Below it is the Prosser, which is a fairly finely bedded limestone. Below that is the Cummingsville, which is full of many large shale horizons, which tends to stop cave development. And below that entirely is another large, thick shale unit, which completely prevents water flow and represents the local ground base level that we can get to. So here we're going to look at a few different cave surveys and see what we can tell from them. And the first one here is Spring Valley Caverns, and we can see that it has a total length of 5.72 miles. It's divided up into several different parts. There's 1, 2, 3, and then 4 and 5. There are several entrances to this cave system, and as we can see from the colors, most of the cave is in this black color here, which is the upper level. The lower level is in the blue or the gray, and we can see that really most of the cave forms on one level. And this is chiefly due to the fact that the limestones in Minnesota and Wisconsin are almost perfectly flat. There's no tilt to the beds at all. They are deposited flat and they're still flat. So this has led to very extensive horizontal development, but not very much vertical development. The other thing we notice is that we get long straight passages that tend to run in an east-west and then a northeast-southwest or a northwest-southeast direction. And these basically represent the 3 major joint sets in the limestone. So when the limestone was forming, it gets these joints that form in there, breaking up the blocks. And the major predominant one is the east-west joint set in Minnesota. And so many of the caves develop along these and these long straight passages. Again, here we can see in Holy Grail Cave much of this east-west passage development, and the predominant joining passages between these long ones are running in the northeast-southwest direction, although we do have a few in the northwest-southeast direction. Holy Grail Cave was an interesting cave. It's actually got quite a large amount of soil over the top of it and had no natural entrance until 2008, when a large supercell thunderstorm came by and dropped 11 inches of rain, after which in a farmer's field there was a large hole. It's actually right about here in Discovery Dome, and this is where the cave roof had actually collapsed in, and when the water drained away, the cave could be entered through there, and it was found to be this really huge cave system, and it's been being explored now for several years. This is part of the Minnesota Caving Club and part of their karst preserve run by John Ackerman. Another one of John's caves, TYSON Spring Cave. This is actually a river cave. It's all on one level, and really it's not quite as joint controlled as the others, but we can still see large sections of the cave which are running in that sort of east-west direction, and over here as well, large sections which are fairly straight passage, a jog to the side, and then fairly straight passage again. Although it does have a few more sinuous parts to it than the rest of them, it is still quite heavily joint controlled with large straight sections of passage following those classic sort of joint set patterns, giving us these nice sort of boxy cave passages. Another cave is Goliath's Cave. This is part of a state scientific and natural area and not very easily accessible. But again, you can see the very straight passage direction running along these joint sets. Some of it mostly in a sort of east-west direction, with the classic northeast, southwest joining passages and making these sort of box sections and loops within the cave. But we can get areas like over here, which runs for probably close to 1,000 feet, almost in a dead straight line. And that's fairly common in the caves around here. Now this cave is South Portal. This is actually part of the Crystal Cave property just in western Wisconsin, and has been dug out by one of the members of the Minnesota Speleological Society, Dave Gerbath, and he has been digging this out for many years. This is actually formed in a much lower unit than the other caves we've been discussing. This is one of these Prairie de Chêne from the bottom of the ore division. It's a very sandy dolomitic limestone, and these were very heavily filled with glacial sediments, such that when we started digging them, they typically only have a few inches of airspace above the sediment and have to be dug out completely. But again, we can see that very sort of in across joint controlled nature to the cave, where we have these long straight passages and then a sudden turn and a long straight passage, a little jog to the side, a long straight passage. The total length so far excavated is just a little over 1,100 feet, and to this day we're still going. There is some airflow in the cave. It should join to the commercial Crystal Cave at some point. So now we're going to look at a few pictures and see if we can tell any of those features that we've just been talking about. So Mystery Cave is the first one we're going to look at. This is a state park in Minnesota. It's run by the DNR, and these photos are all by Al and Chris Luera and myself. And Mystery 2 is where many of these pictures will come from. Although it's run as a show cave in parts, it's an undeveloped show cave, so they don't have any lighting in there, and some of the floor has not been modified, so it's only flashlight tours. But here we can see large vertical passage, nice straight walls. You can see the thin limestone beds with small shale horizons in between. This is classic of the upper Dubuque into the Maquoketa Formation. And we can see the very flat ceiling and the floor made up mostly of breakdown blocks. Again, here we see another passage. This is 5th Avenue, and up here we have 4th Avenue. And these are running along a predominant joint direction in the cave, and these passages will go for hundreds or thousands of feet in a dead straight line without any turns. Again, in the walls we can see the very thin limestone beds and the very flat roof, with occasional step-ups to higher levels, but generally pretty flat at one level. The floor here is, of course, not natural. This has been modified by the state with pea grit and clay to make an easy walking surface for the tours. Here in this view, we can actually see up at the top of the cave the original inception horizon for the cave. So we can see this small domed roof. This marks the level where the water first came in under pressure in the water table as a phreatic cave development. and then shortly afterwards became vadose and dug down as a trench. And we can see the slightly wider passage here, and then it widens out a lot, gets a bit narrower, and then widens again underneath. And there are two main reasons. It could be that this layer was slightly weaker and therefore more easily eroded, or it could be that the water flow increased or the sediment load increased and caused more erosive power. But again, we can see that the actual general trend of the passage is along the joint in the rock, and we can see in the continuing wall in front of us several joints which have been partially eroded and widened out. Some of these, like this one over here, are passable by people. Some of them on the one on the right here are not. The main cave passage here actually takes a little jog to the side and then carries on parallel again in another joint to the side. Again, here we have another view of a nice long straight joint controlled passage, nice vadose passage. You can see the horizontal limestone layers in the side. These passages, I say, go for hundreds or thousands of feet in a straight line. Whilst there isn't any active streamway in the upper cave, there is in the lower levels, but those are generally not accessible. The passageway is too narrow for people to get into. But in the upper levels, we do have some water features. This one is a lake called Blue Lake, and its prominent feature are these raft cones. The water evaporates, deposits calcite rafts on the surface, and drips from the ceiling come down and sink them. And when the drip keeps happening in one place, over time it builds up this cone. These are typically underwater, but occasionally the lake dries out and you can stand next to some of these cones at the bottom. And some of these big ones in the middle are well over 6 feet tall. Again, the joint-controlled nature of the cave can be seen in many of the passages as these large cracks in the floor which require either straddling over or crawling besides, trying to avoid the formations the whole time. And again, another example where there's a joint in the cave and the passage at the top is wider, it can't be passed at the bottom, so you have to chimney up here, crevice along, and then chimney back down on the far side. This is another part of the cave where a large formation is actually blocking one of those side joints between two of the main long passages of the cave. So there's actually a small way underneath that was dug out through part of the formation, and then through this pool where we have these boards to keep you out of the water. Behind that, though, is another lake caused by the fact that the cave is dammed up by another large formation just where the passage comes in again. And we have to cross this lake, scoot around the edge of the formation, and then carry on down walking passage. But again, super flat roof, big wide passage, horizontal limestone layers. So then over in Wisconsin, we have Crystal Cave. It's the longest cave in the state. It's a privately owned show cave, and there's their website. As I said earlier, it's formed in the lower ore division as opposed to the upper ore division, like many of the big caves in Minnesota. And so this is in the Prairie de Chêne group. It's a sandy dolomitic limestone. It didn't erode as much due to the more sandy and dolomite nature of the cave. It wasn't quite as erodable as the pure limestones. And it was filled heavily with glacial sediments. You can see the level here on the wall. There was maybe 6 to 10 inches of space above it, and it's all been dug out down to at least hands and knees crawling height. The boards are placed on the floor to allow us to drag cartloads of mud out of the cave more easily. Due to the nature of the stone, it tends to form small chambers with little passageways that duck under to go through, and it's very multi-level. It goes up and down quite a bit within this unit of rock. We have lots of little multiple holes that could be possibly widened to make it through. We can see here again the joint controlled nature of the cave. This is a fairly straight passage that takes a 90-degree bend and then goes 90 degrees again to keep going, which can make moving through it sometimes quite difficult. This gentleman here is Blaze Cunningham, a former owner of the cave, and it gets a bit tight trying to get around some of these small corners. Again, here we can see the very blocky nature of this limestone, this dolomite. and the fact that it makes many little openings, it's kind of hard sometimes to figure out which one's going to lead you around the blockage as you're digging through the mud. You may come up against a rock and you think it's a wall, but then like 5 inches to the side there's a hole. And again, here we can see just the fact that we only dug it down to crawling height. We didn't extend the digging down any deeper. We don't actually know where the floor of the cave is. It could be walking height, but that would be a lot more sediment to move. And with that, I thank you for listening to me, and well, this is the end. Thank you.